Alright, now we're going to talk about using u substitution with the definite integral. We already talked about u substitution with the indefinite integral. And we already talked about just taking the definite integral, how that's the antiderivative, and then you plug in your upper and lower limits, right? So we already talked about this, right? If you have some integral of f of x from a to b, that this is going to equal the antiderivative with b plugged in minus the antiderivative with a plugged in. So, but now we have one more thing that we're going to accomplish, and that is, what happens if we have to use the u substitution with a and b? Well, let's go to the next page. So all the same stuff is going to be the same that we did before with the u substitution, but with one little extra caveat, and that is that these limits are in terms of x's. These represent x's. And so what we're going to do is we are going to change them into u's. Since we're going to be plugging this in as a, so we're going to be using u substitution, we're going to plug these in terms of u. So, let me show you what I mean. In this very first problem, this is supposed to be an x squared, by the way. If we were to treat this x squared plus 1, if we were to treat that as our u, we would say u equals x squared plus 1. Let's go through all of our normal steps. That means that du equals 2x dx. And look, 2x dx, there's a 2x dx. So, we could write our integral symbol. Don't write your a and b yet. 2x dx is the same thing as du. And instead of x squared plus 1, we could put just a u, and it's u cubed. Now, here's the thing. These are x values, and since we're talking about u, we want u's. So it's pretty easy to do. We could kind of just do it in our head, but basically what we want u of 2 and u of 0, if you think about that. So we got 2 squared plus 1, and we got 0 squared plus 1. 2 squared, 4 plus 1 is 5, 0 squared is 0 plus 1 is 1, so now this would be 1 and 5. And it works. This will give us the exact same area under the curve, just a lot simpler function. So we can do this. So, yeah. Now we can go ahead and take the integral. Let's go ahead and do it. So the antiderivative of u cubed is u to the 4th over 4. We're going to evaluate that from 1 to 5. So that means 5 to the 4th over 4 minus 1 to the 4th over 4. Let's see, what is 5 to the 4th? That's 625 minus 1 all over 4, which is 624 over 4, which that is divisible by 4. 624 divided by 4 is 156. So this whole thing is 156. So that's the trick to remember here. Same process with u substitution. It's just that you also have to plug in these x values and get new u values like I did here. So let's go on to the next page. Alright, so here it is with the trig function. No difference in the plan here. This one actually isn't all that complicated because this is a pretty simple substitution if you think about it. But let's just go ahead and do it anyway. Let's just say that this is our u. So u equals pi minus x. So du equals simply negative dx. And unless there's a negative dx exactly over here, we're going to want to substitute that. So we could say that negative du equals positive dx. Okay. So let's rewrite our integral. It's cosine u. And instead of just d, we know the dx equals negative du. So I'm going to put a du here, and I'm going to put the negative out in front. And now we also need new limits. So first, let's do the u of pi fourths. Well, that equals pi minus pi fourths. Or you can kind of think of this as 4 pi fourths minus pi fourths. So this is now 3 pi fourths. Alright, what about u of 0? Well, that's pi minus 0. Well, that's just pi. Okay, hopefully you notice something here before we take the antiderivative. I'll give you a second to just think about it. Our u substitution has caused our limits, our upper limit, to be less than our lower limit. So this is wrong. This integral is written incorrectly. So that's okay though, because we know we could switch these two by just changing this sign. So now this is really the positive integral of 3 pi fourths to pi of cosine u du. Pretty cool. So let's go ahead and take the antiderivative. Remember, the antiderivative of cosine is simply sine. So this is the sine of u from 3 pi fourths to pi. All right, we're ready to evaluate. This is simply the sine of pi minus the sine of 3 pi fourths. And the sine of pi is 0. If you just visualize the unit circle, right? Here's pi. So the sine of pi would be, well, this coordinate is -1, 0. So the sine is the y value, so that's 0. Minus 3/4 pi. Well, 3/4 pi would be right here. And again, this is the y coordinate. So the middle one, if you remember, this is negative rad 2 over 2, and then positive rad 2 over 2 because it's the y coordinate. So this is minus rad 2 over 2. So that means this is our whole answer, just negative rad 2 over 2. Pretty cool. All right, let's try the next problem. All right, well, this is one of those problems where it's probably going to be helpful if you rewrite it as an exponent. So from 0 to 2, 2y minus 1, parentheses to the 1/2 power dy. And now you can see our innermost part is going to be our u, so u equals 2y minus 1, which means that du equals 2 dy. Alright, I'm not seeing a 2 dy in here, so I'm just going to go ahead and solve for dy, which means I'm going to divide by 2, divide by 2. So dy equals du over 2. Alright, that should be easy enough to substitute in. Let's go ahead and start writing that new integral then. It's going to be the integral. And instead of 2y minus 1 to the 1/2, it's just going to be u to the 1/2. And instead of dy, it's going to be du over 2. But instead of just putting it over 2, that's the same thing as 1/2. So I'm just going to put a 1/2 out here. Remember, we're allowed to just put coefficients out in front. Alright, now we just have to evaluate the limits, right? So what is the u of 2? Well, it would be 2 times 2 minus 1, so this is 3. And what is the u of 0? Well, it would be 2 times 0 minus 1, so this is -1. Alright, they're still in the correct order, so that's good. So we can go ahead and evaluate this thing. The antiderivative of u to the 1/2, remember you add 1 to the exponent, so this becomes u to the, let's keep our 1/2 out here, u to the 3/2, and then divided by 3/2. And we're evaluating this thing from -1 to 3. I don't know if I've shown you these brackets or not yet. You could use the brackets and put the numbers out here. It means the same thing. Okay. So let's clean this up just a bit. If I was to distribute this 1/2 in, and if I was to flip and multiply, what would this really look like? It would look like, let's see, if I flip the 3/2, it would be 2/3, right? So we could go ahead and write a 2 and a 3, and with a u to the 3/2 on top. And then remember, I'm going to multiply in this 1/2, so that's kind of like saying 1 times 2 over 2 times 3. Well, these guys would cancel out. And remember, we're still evaluating this thing from -1 to 3. Alright. So this thing would really look something like simply u to the 3/2 over 3 from -1 to 3. Alright, now we can plug everything in. That means we have 3 to the 3/2 over 3 minus -1 to the 3/2 over 3. Now, this is not exactly a nice, neat problem. So I'm just showing you we could do all the calculus here, but at the end, we're going to run into a slight problem. I'm going to show you what it is. First of all, we know these are both over 3, so let's just give them a common denominator, 3. And 3 to the 3 halves, we could really write that as the square root of 3 cubed. And then this is minus, and what's going on here? Let's think about this. Well, negative 1 to the 3rd power, that's still just negative 1. So this is really just negative 1 underneath the square root. Well, that's an imaginary number, right? We can't have a negative underneath the square root. So I'm going to leave this as a complex number, and that's okay. But in order to do that, we have to really think about what's going on here. So I'm going to say that we do this. Let's write it as, and I'm just going to focus on just this part real quick. Remember that a negative 1 underneath the square root is equal to I, right? Well, what you right now you have is a negative 1 underneath the square root to the 3rd power. So that's like I to the 3rd power. And if you remember your rules, you have I, then you have I squared, then you have I cubed, then you have I to the 4th, and then the pattern just repeats because this is just square root negative 1, but if you square it, you get a negative 1. And I cubed, well, isn't I cubed I times I squared? So I cubed is really an I times an I squared, and I squared is really negative 1, so I cubed is really negative I. So this whole thing on top is a negative I, so you have a negative, or you're minus a negative I, so this is really like saying plus I. I know there's a little bit of review of complex numbers, but we can leave our answer like that. I guess we could cube the 3 there and make this the cube root of 27 plus I over 3. It's not pretty, but it's still an answer. It's still an algebraic answer to this integral. And the reason why we're getting an imaginary number here is because if you think about it, this graph doesn't actually even exist at 0. Right? If you were to plug in a 0 here, think about what would happen. 2 times 0 is 0 minus 1. You'd actually start off with an imaginary number, so it doesn't even exist on the real plane. So that's why we're getting an imaginary answer for our area, because this thing doesn't exist on the real plane. It doesn't start existing until y equals 1/2, right? So the limits here don't work. It's something to kind of consider. So that's why we get an imaginary solution. All right, let's go to the next page. Okay, similar type of problem. I think that you guys can do this one. Remember that the 4 here, this is a coefficient. It could just go out front. There's your u. I want you to pause the video, give it a try, and then check back when you're ready to check your work. Okay, a couple things to think about in this problem. Your u is going to be just basically 1/2 t, or t divided by 2. So the du equals half a dt, so when you solve for dt, you get just simply 2 du. And then you're going to change your limits. Your u of pi halves is pi fourths, your u of 0 is 0. So if I plug all that in, I get this. That gives me a 2 here and a 4 here, so I just pull it out and make an 8. The antiderivative sign is negative cosine. So that gives me basically negative 8 cosine u as my antiderivative. And so then I'm going to just plug in my limits. So negative 8 cosine pi fourths minus a negative 8 cosine 0. Well, that double negative obviously turns into a positive. And so here I get a negative 4 rad 2, and here I get a positive 8. So my answer is simply 8 minus 4 rad 2, which is, you could write as a decimal expression, but we don't really need to do that unless they ask for it. All right, got one more problem here. I think, again, you could do this one on your own. Remember, do u substitution, and looks like you're probably going to need to use negative exponents here. Give it a shot, and again, just pause and unpause the video when you're ready to check your work. All right, so we're going to need to substitute in our u, so that's 3 minus 5x. Therefore, du is negative 5 dx, and if you solve for dx, that's negative du over 5, or you could kind of think of this as negative 1/5 times du. All right, then your new limits, 1 and 2. You plug in a 2, you get negative 7. You plug in a 1, you get negative 2. So you got to rewrite this. Instead of a negative du over 5, I'm just going to put the negative 1/5 out front. Here's my new limits. Instead of a u on the bottom, or u squared on the bottom, I'm just writing as u to negative 2 du. So this equals negative 1/5, sorry, I got a little sloppy here, negative 1/5 times u to the negative 2, you add 1, that's u to the negative 1 divided by negative 1. These negative 1s cancel out, so what you're really looking at, if you put the u back on the bottom, is 1 over 5u, and this is from negative 2 to 7. All right, if you plug in a negative 7, you get negative 35. You plug in a negative 2, you get negative 10, but you're subtracting, so that turns into adding. common denominators would be 70. You'd have to multiply this by 2 and multiply this by 7. So you get negative 2 plus 7, which is 5/70, which reduces nicely down to 1/14. So the answer to this thing is 1/14. All right. See you guys on the next video.